Assalamu alaikum. In this part of vector generalities, we will talk about how to prove collinearity and parallelism of lines using vectors and how to prove collinearity of points using vectors. Get ready and prepare your textbook, pens, draft papers, copybook, and calculator. Collinear vectors. Two vectors are said to be collinear if and only if they have the same direction. What do we mean by same direction? As we said before, same direction means that they are on same line or on parallel lines, as shown in the figure. Here, u vector and v vector are on the same line, so they have same direction. In this figure, u vector and v vector, here is v vector, here is u vector. They are on parallel lines, so they have same direction. Property 1. U vector and v vector are collinear vectors if and only if there exists one and only one real number k such that u vector equals kv vector. You must write the first vector in terms of the other vector multiplied by a real number k that is different from 0. Property 2. U vector equals kv vector. This means that u vector and v vector have the same direction. But what about the sense? The sense of these two vectors changes according to the real number k. If k is positive, then the two vectors have the same sense. But if k is negative, then the two vectors have opposite senses. And according to the relation u vector equals kv vector, we can find the magnitude. The magnitude of u vector equals absolute value of k multiplied by the magnitude of v vector. Example. If we have AB vector equals 2 MC vector, this means that AB and MC vector are collinear vectors. They have the same direction. AB and MC are parallel lines. AB vector and MC vector have the same sense since MC is multiplied by 2 and 2 is a positive number, and the magnitude of AB vector is equal to 2 multiplied by the magnitude of MC vector. DC vector equals minus 4 multiplied by BG vector. This gives us that DC vector and BG vector are collinear vectors. They have the same direction, they are on parallel lines. They have opposite senses. Why? Because BG vector is multiplied by minus 4, which is a negative number, and the magnitude of DC vector is equal to 4, the absolute value of minus 4, multiplied by the magnitude of DG vector. Application. Pause the video for 5 minutes and try to solve this application. In this application, we have segment AB and a point C that does not belong to the line AB. You need to locate point D in each of the following cases. Pay attention that in the first case, CD vector and AB vector are collinear vectors. They must have same direction and they must have same sense since AB is multiplied by a positive number which is 2. And the magnitude of CD vector equals 2 multiplied by the magnitude of AB vector. Part 2. Pay attention that CD vector and AB vector are collinear vectors. They are on parallel lines and they have opposite senses. Since minus 3 is a negative number, the magnitude of CD vector will be absolute value of minus 3 multiplied by the magnitude of AB vector. Application 2. Pause the video for 10 minutes and try to solve this application. In this application, you have ABC is a triangle and 2 points E and F such that AE vector equals 1 over 3 AB vector and AF vector equals 1 over 3 AC vector. In the first part, you are asked to write EF vector in terms of BC vector. Pay attention for the given and start by EF vector. Insert point A between E and F, and according to ch3 rule, you will have EA vector plus AF vector. This will take you to EF vector equals opposite of AE vector plus AF vector. So EF vector equals minus 1 over 3 AB vector from the given plus 1 over 3 AC vector also from the given. EF vector equals 1 over 3 BA vector plus 1 over 3 AC vector. Take 1 over 3 as a common factor and you will have BA vector plus AC vector, which is BC vector. So EF vector equals 1 over 3 BC vector. Part 2. What can you say about EF vector and BC vector? Since EF vector equals 1 over 3 BC vector, this was proved in part 1, then these two vectors are collinear vectors because they are written in the form of U vector equals KV vector. Collinear points. 3 points A, B, and C are said to be collinear if and only if AB vector and AC vector are collinear having point A in common, or AB vector and BC vector are collinear having point B in common, or AC vector and BC vector are collinear having point C in common. What does this mean? This means that you need to form two vectors out of these 3 points and they must have one point in common. Example. Given the 3 points A, B, and C such that AB vector equals 2 AC vector, prove that C is the midpoint of AB. As we said, since AB vector equals 2 AC vector, then these two vectors are said to be collinear because they are written in the form of U vector equals KV vector. So AB vector and AC vector are collinear vectors and we have point A in common, then the 3 points A, B, and C are collinear. Also, AB vector and AC vector have the same sense since AC is multiplied by 2 and 2 is a positive number, and the magnitude of AB vector equals 2 multiplied by the magnitude of AC vector, then C is the midpoint of segment AB. Application 3. Pause the video for 5 minutes and try to solve this application. In this application, you have AB vector equals 2EF vector and AC vector equals minus 3EF vector. Show that A, B, and C are collinear points. As we said before, in order to show that 3 points are collinear, we need two collinear vectors having one point in common. We will start by the given. AB vector equals 2EF vector, then EF vector equals half AB vector, and AC vector equal minus 3EF vector. So we can substitute and we will get AC vector equals minus 3 multiplied by half AB vector. So AC vector equals minus 3 over 2 AB vector. These two vectors are collinear having point A in common, then the points A, B, and C are collinear points. At the end of this video, you are asked to review the core section and solve exercises 5, 6, 8, 13, and 14.